Imagine you are standing on a city sidewalk, the solid concrete beneath your shoes feeling like the most stable thing in existence. But if you could suddenly drop straight down through the pavement, your world would change in an instant. First, you would zip past subway tunnels where commuters check their phones, then through deep military bunkers designed to survive nuclear strikes. Deeper still, you would encounter high-tech laboratories hidden in the dark, then the hot, cramped tunnels of the world's deepest gold mines. Eventually, you would pass the tip of the deepest hole ever drilled, a tiny needle prick in the planet's skin. Beyond that lies the vast, mysterious mantle and the crushing, white-hot core of the Earth itself. Humans are obsessed with the sky. We have built telescopes that see back to the dawn of time, and we have sent astronauts hundreds of thousands of kilometers into the vacuum of space. Yet, when it comes to the ground beneath us, we are remarkably shallow travelers. How far have we actually gone into our own planet? The answer might surprise you. The deepest hole ever drilled by human hands is just over 12 kilometers deep. While that sounds impressive, it is barely 0.2% of the distance to the center of the Earth. To understand why we are stuck so close to the surface, we have to look at the incredible physics of the underground. The greatest obstacle isn't just the hardness of the rock. It is how the rock itself begins to behave like a liquid the deeper you go. To truly understand our progress, we need to reset our sense of scale. The Earth is a massive sphere, roughly 12,756 kilometers wide. If you were to drive a car from the surface to the center, a journey of over 6,000 kilometers, it would take you days of non-stop driving at highway speeds. In comparison, our deepest achievement, the Kola Super Deep Borehole, reaches only 12.262 kilometers vertically. If the Earth were the size of a large apple, humanity's deepest hole would not even penetrate the skin. It would be a nearly invisible scratch on the surface. If you placed Mount Everest inside this hole, the peak would be buried with kilometers to spare. Even the Mariana Trench, the deepest point in the ocean, is shallower than the deepest hole we have drilled. To navigate this journey, we must answer three distinct questions. How deep can a human physically survive? How deep can our machines drill? And how deep might our future technology eventually reach? First, let's go as deep as a human can actually breathe and work. We explore below, mostly below the surface. We enjoy shallow layers. Consider our metros, traffic tunnels, and railways like the Channel Tunnel. These are usually tens of meters deep. Our most secure military bunkers and underground communities rarely exceed a few hundred meters. We keep near the top since every meter of depth causes exponential issues. To develop deeper, we must remove tons of heavy, expensive rock. Pumping fresh air down and stale heated air out makes ventilation a nightmare. Emergency escape routes are needed as groundwater pressure seeks to fill tunnels. The engineering challenge of supporting the rock above becomes more risky with each step down. Some industries must exceed these restrictions. We must look to mining for the deepest human residence. The world's deepest gold mine is Mponeng in South Africa. 3 to 3.5 kilometers below the surface are active mining operations. Extreme circumstances exist here. Workers descend down various shaft systems to reach the mine face, which might take over an hour to get to work. Rock can reach 60 degrees Celsius at these depths. Without huge, high-powered cooling systems and ice slurry circulation, humans would die within minutes. The rock's enormous strain can cause rock bursts, where the tunnel walls fracture outward due to the mountain above. Regular human work is limited to this. After this, we build holes for machines, not tunnels for people. A startling diversion is required before we can examine those machines. Not every deep world construction is for gold or transport. Some are for the universe's most delicate science. The China Jinping Underground Laboratory, hidden beneath 2,400 meters of mountain rock, is a scientific miracle. This lab was designed for stillness, not mining. Scientists exploit the mountain's thickness to filter cosmic radiation by conducting experiments deep down. This lets them search for dark matter and discover uncommon particles that would be lost in sea-level noise. Interestingly, scientists can drive into this mountain-based lab using a horizontal tunnel, but they haven't plunged through a vertical hole into the crust beneath 2.4 kilometers of rock. A brilliant shortcut to the deep. Though excellent, this facility is nowhere near humanity's deepest Earth penetration. The Kola Super Deep borehole in Russia is honored. This Soviet-era scientific race to the bottom mirrored the space race. How deep we could penetrate the crust to see what was there was the goal. The drill reached 12,262 meters by 1989. The greatest true vertical depth humans have reached in almost 30 years. It wasn't a big open pit. The pit bottom was 23 centimeters broad. One could never fit inside. At that size, kilometers of steel tubing powered the drill bit like a wet noodle. Since fishing from 12 kilometers below was nearly impossible, broken equipment was often lost forever. Although money was available, the Earth fought back, terminating the Kola project. We now reach our scientific goal. How could they not continue? Challenges multiply exponentially. The first is heat. Geologists projected a 12 kilometers 100 degrees Celsius temperature. It was 180 degrees instead. Drill bits and electronics failed easily at this temperature. More importantly, the rock behaved differently. Extreme heat and pressure soften deep rock. Becomes plastic. Instead of splitting smoothly, the rock flowed like thick rubber or hot honey. The hole squeezed closed as engineers replaced the drill bit, deforming the crust above. Beyond the changing rock, logistics are astounding. Each bottom-cut rock particle must be raised with drilling mud. Heavy drill strings can stretch or shatter metal. Distance hinders progress. They struggled for every meter in the Kola project's final years, driving up costs. Underground exploration fails due to heat, pressure, distance, and time, not walls. Could we reach the mantle? To grasp the challenge, look at Earth's layers. The thin, stony crust is where we live. The liquid outer core and solid inner core follow the mantle, which extends roughly 2,900 kilometers below. The mantle can be reached faster by drilling through the ocean floor. Continental crust is 30-50 kilometers thick, while oceanic crust is 5 to 10 kilometers thick. However, this causes new issues. A drilling platform must be operated from a ship through kilometers of flowing water to drill into the seafloor. Despite its appearance as a sea of flowing lava, the mantle is primarily solid rock that flows slowly over millions of years. Reaching it would be a huge scientific achievement, but the planet is just beginning. Future technologies may break the Kola borehole record. Engineers are testing non-contact drilling with high-energy plasma or powerful lasers to melt rock instead of crushing it. Self-sufficient machines could bore deeper without a drill string. This is economically beneficial due to geothermal energy. We can use the Earth's infinite heat to power the planet cleanly if we delve deep enough. How about the core? Could we reach Earth's center? Current physics says no for the foreseeable future. The Earth's center lies over 6,000 kilometers below. At 5,400 degrees Celsius, the inner core is as hot as the sun, pressurized millions of times higher than sea level. A human-sized tunnel to the core is impossible. The energy needed to cool and prevent it from collapsing would be more than our modern civilization. Even the most advanced machines would melt and crush before reaching the upper mantle. The ladder of depth shows our limits. We dwell in surface light. 4 kilometers below, our miners endure the heat. Our scientists bury their most sensitive gadgets in mountains. Our best machines have etched 12 kilometers into the crust. Earth remains a vast foreign universe beyond that. We have documented the moon's craters and Mars's plains, but seismic waves reveal 99% of the globe beneath our feet. The final frontier lies beneath our feet. Given how risky it is to descend, would you rather descend into the dark, hot depths of the world's deepest mine, or take a submarine to the crushing silence of the ocean floor? Which extreme scares you more? Share in the comments.